Okay, so Borromean rings are a very, very interesting kind of object. So you have three rings. There's one ring, and there's another ring. And you make another ring and link them together. So if we go down through that one, up through that one, and back down through that one. And then we tie these two together. Try and get my hand out of the way. There we are. We have the classic Borromean rings. Interesting for lots and lots of reasons. I think for me the most interesting and probably the most trivial thing about the Borromean rings is that if you remove any one ring, the other two will fall apart. So it's kind of like symbolic of a trinity or something. I mean, it's like if this ring here, it wasn't there, then these two here would be separable. Another interesting thing about them is it seems to have something to do with the sphere. I mean, you can set them up like this, and then they have this almost kind of gyroscope kind of quality that each circle can revolve separately. Yes, so there's lots of reasons why Borromean rings are interesting. But what I wanted to do is to show you a sort of fractal structure, which I thought of. I mean, maybe some other people have thought of it too, based around the Borromean rings. So the idea is very simple. To make Borromean rings, you get three rings and link them round, as I've just shown you. Now, what you can do then is you can pull them together like this, so you just look like it just looks like one ring, and then you can get three copies of something like this and make an extra sort of Borromean ring of Borromean rings, if you like. So I made one of those. Here's one I made earlier. Where is it now? Here it is. So each of these is actually a Borromean ring. So we can unfold it like so. And we have this sort of nice floral pattern going on. Another thing we can do, we can just carry on this process of iterating. So if we make this into like a loop, we can then make three copies of this. And I mean, it's like building a fractal structure. You know, you make three copies of this and make a Borromean ring of Borromean rings of Borromean rings, and so forth. I'm not sure what kind of properties they have. I mean, each Borromean ring defines a surface. I did another video on how the Borromean rings define Sierfret surface. But what kind of surface this thing defines, it would be a very interesting study, I imagine. And then there's also the matter of, you know, a single Borromean ring makes something, it seems to naturally make three circles in a sphere, as I just showed you, like a gyroscope. So I don't know what kind of mechanical properties one could get with something like this. It's really just play.